Hi, my name is Norman and this here is a Anycubic Mega-S. To be honest, it has been modified quite a lot since it came into my possession. Well, the X-Carriage is replaced. Also, I upgraded the heat bed to receive a magnetic heat bed because that's just a lot more convenient. Also, I think I did some changes on the inside. And this is where we are going to tinker today. We are going to install these little bad boys here. So we're talking about silent stepper drivers. So let's get started, right? Okay, let's just get these cables out of the way. Don't mind that dying plant over here. We actually do have a Raspberry Pi installed with a little 3D printed bracket which I designed. At the moment it's not in use because it's making a bunch of problems. I don't know why. It just doesn't seem to work stable enough. Yeah, I think I need to just reinstall that. But because I am too lazy, I have been using that SD card. I actually already installed motor dampers. These are, pieces of rubber you can screw in between your motor and everything else probably. I installed one of those actually to every motor except the extruder here in the back. It's going to dampen the vibration coming from the motor. That already helps a lot with the noise. Let's open up this puppy. As you can already tell, bright and orange. The power supply has also a different housing. People who own this printer know that it's crazily loud. Well, one way to solve it is to replace the fans with much quieter ones, and this is what we did down here. So, you see we have two very large, ugly brown fans. That's like the Noctua signature color. They are known for being very quiet. I reprinted that in PETG because it's heat resistant, mainly to just fit a larger fan inside. For my other printer, I actually just took the original housing and cut a larger hole because it's very, very thin sheet metal. Use a Dremel or something. So if you want to, silence your Anycubic Mega-S or Mega, it's worth thinking about replacing the power supply fan with a larger one and also with a, ultra silent PC fan. I made these modifications a while ago already, so I'm not sure if I'm going to find these STL files where I found them last time, but if I find them, I'm gonna link them down below in the description. For that and also for the X-Carriage on the other side here. Description. Okay, as I mentioned before, we are installing new motor drivers. The type of the motor drivers is TMC2208 from Big Tree Tech, not sponsored. I just have been using them in this printer already, and I thought, yeah, I'm very satisfied. Might as well just buy them again and use them in this one. Of course, to build in these motor drivers, we need to remove the old ones. So we're getting this large fan here out of the way. Oops. Very, very dusty inside. That's probably not very good. Yeah, would be really cool if we had an air blower. Now we got dust everywhere and the majority of dust is still inside here. So here, looking at that, these red components here are the motor drivers. They are interchangeable. In case one of those breaks, you don't need to replace the entire board. You can just replace one of those. They're actually perfectly fine, a very good condition still. So it's kind of a pity to remove them. Yeah, I don't know where I'm going to use so many motor drivers. Yeah, we don't need these jumper wires here. So we're gonna keep them, put them into the box. We need to install the heat sinks. I'm gonna leave these things on this foam here for the sake of convenience. So this is double-sided tape on each heat sink. The only thing which we need to think about is that these things are going to sit inside on the main board that way. So because we want the air to flow that way, I'm gonna see that later. I'm gonna, the orientation of these heat sinks. I don't know if that's really, really relevant because, to be honest, the air can flow in both ways pretty good, I think. It just feels better for me. So there you go, heat sinks installed. These little screws here, they are to adjust the current flowing through the motor. Actually, in my whole life, never here and never there I had to adjust them. So everyone tells me to adjust them, but I always felt that the motors are doing just fine. Maybe they come pre-adjusted, so yeah, I won't touch them. But if you feel like your motor is, you know, these things are running too hot, or your motor is too weak, it might be worth looking at those and also measuring. There's a smart way to adjust them. That's not just like trial and error. Yeah, we're not gonna talk about that today. So now, and the last thing to do is actually installing these motor drivers. And the only thing which we need to care about is, well, the orientation. You can see here, it says GND, or you can't, but just gotta believe me. It says GND, ground. So we're gonna align the ground pin with the ground pin of these, a lot of pins. So the ground pin here is top left, and the ground pin here is also top left. So that's probably the correct orientation. And there you go, looking nice. I love the blue heat sinks, just look at them. Now the gibberish from before makes a lot more sense. All the heat sinks are that way, so that the air can pass through to the outside. Down below there are some holes on the case of the printer. Here you can see them. Yeah, the air needs to go somewhere, and I hope it's going out of the case. Actually, that's a very, very close fit. I'm going to try to bend that bracket here a little bit, because here these heat sinks are too high. But as far as I can remember, I also have that fan in the other printer, and I didn't need to, you know, modify anything. So I think that fan is going to work. So, and there you go, that's it already. We just need to close it up, and then we're done with the hardware part. Oh, by the way, some people may have noticed this thing is actually the wrong way around. It's supposed to go on that way. But then I realized that, you know, why is it closed here? Even with the stock fan, it would just... I don't get it. That's why I just flipped it over, so that we have very nice airflow from the bottom. Only downside is that these screws here on the outside don't fit. So the corner screws still do. Oh, right, and these screws here also don't fit. I'm not that concerned about the screws at the bottom cover, because, yeah, as long as it doesn't travel sideways, I'm cool. Yeah, that fan still can spin freely. That's great. So there you go. And yes, if you are concerned about putting your printer sideways, don't do it. But I think these things are built to be as rigid as possible. I believe that it's not going to harm the printer. I hate that jingle. And I'm so happy that now we are going to install the new firmware, which is luckily, it doesn't include that jingle anymore. On boot up, that printer is going to stay silent. Well, sometimes you need that jingle for debugging or whatnot, but most of the times it's just annoying. We're going to install the new firmware now, so that the printer actually knows that it has the new drivers. I don't know what happens if I try to move the motors now, and that's why I'm not going to do it. Well, actually I was expecting it to be like an easy run here, but to be honest, yeah, it has been a while since I did that on the other printer, and now I cannot find it. I can't remember which one of those I took, because back then there was only one available. So I remember the instructions to be German and English, and German first, which is kind of weird. So I'm not sure if this is the one, but if this is the one, I'm going to link it down below in the description. For now, we're just going to download it. So there are download instructions here how to do it. Here's the English version. You can hit the pause button to see, to read it, or you just don't care. I think I need the one with TMC and S, because I got the Titan extruder on that one. So we're going to look for the STMs. Jeez. I'm just going to try out the Mega-S TMC 1.19 hex. Download. You can also just download the regular Marlin firmware and compile it yourself, because I don't feel like compiling today, I'm just going to download the ready compiled hex file. So now it gets complicated. Because, well, usually you can just use that Raspberry Pi, it has Octoprint installed, I can just access the network interface and do it over the internet or local network, whatever. Because I know that not everyone has that, and also this one has been kind of bitchy lately, I'm just going to use a direct USB connection to the computer over there. This would have been a little bit easier if I had a laptop, but you know. Okay, so one thing you need is I think what's called a USB-B cable. So these are also the ones, if you have a printer at home, a 2D printer, you'll probably also have one of those. So a funny thing, 2D printers and 3D printers use the same type of connection to PC. Yeah, I'm gonna plug this in the mains. I'm actually not sure. I'm not sure if that printer actually needs, you know, mains voltage to have a firmware update, but that's how I have been doing it since forever. So I'm not going to change that, never change a running system, you know. Plug that in. For that thing you need Ultimate Cura. I don't know, there are probably also other softwares to flash firmware. Probably also different softwares, but I found Cura pretty reliable. So you already hear that annoying beep, beep, beep. In the upper left corner, I don't know how it's on Windows, but I think it's also somewhere up there. You go on Printer, Manage Printers, and then you go on Update Firmware. And then you go on Upload Custom Firmware. I think it's pretty straightforward. So then you select the hex file, which you just downloaded, hopefully the right one. And then it's going to update. We are soon going to find out if that was the right one. Firmware, okay, firmware's, that's new. They now didn't delete the jingle, but it's less annoying, so that's also pretty good. We are back here on the other side of the room, because I feel a lot more confident having a piece of equipment moving around far, far away from, you know, a $2,500 computer. At this point we could be done, but not necessarily, because I'm not sure if I downloaded the right type of firmware to confirm. The only thing which I needed to look at, because I don't have a BL Touch, is if the direction of the motor is correctly set up. We are just going to move the axis manually with these little buttons here and see and hope if it's moving the right direction. If you're starting this, of course, you're going to make sure that all your axes are in the middle, or at least have a little bit of room to move, so that if it moves in an unexpected direction, it's not going to hit anything. So let's see, Y plus 10, it should move in that direction. That's great. Minus, because that's 0, 0. X plus should move in that direction. That's also great. Z plus, of course, yeah. Great. Because the motor direction is more or less correct, I also assume that the extruder direction is correct. So now that we know that we downloaded the correct firmware, we could actually start a test print. But before we do that, I just want to make sure that everything is calibrated. So we need to recalibrate, especially the extruder, because, well, that's something you always gotta do for some reason. Usually the belt thing just works because, you know, you have a timing belt and one rotation is always the exact same distance. But for the extruders, it always depends on everything. So it varies between every extruder. You know, you gotta calibrate them, every single one of those. Yeah, we got to do that really, really quickly, but for that I'm going to use the Raspberry Pi, because that's a lot more easier, and the trade-off of not doing it with the Raspberry Pi is huge. So yeah, we're gonna take the easy route here. To calibrate this bad boy back there, I found a really, really nice article on the internet, also of course linked down below in the description. And before we do anything, this printer is currently preheating and we need to mark the extrusion at 120 millimeters. It's easiest to take a caliper and then measure from the stop of that thing here and make a scratch on the other end. So now that dangling piece of filament here has a little scratch at 120. Of course, you can just leave the spool on. I removed that earlier. Yeah, you don't need to remove the spool. Okay, so now this is Octoprint. Yeah, as you can see here, it's already preheated. We can actually set that to 200 just because we can. So I highly recommend for anyone who's into 3D printing and who doesn't have a network capable printer, get a Raspberry Pi, install Octoprint, it's awesome. And you can upload your G-code here directly through the web interface and do your things. Of course, we are not going to print anything for now because we are going to tell the printer to move 100 millimeters. As you remember, we marked at 120 and we are going to move 100. So now it's moving, I suppose. Yeah, there's the blob coming out. Just gotta believe me in that one. And then we're gonna switch over to the terminal, suppress temperature messages because we don't need them. We are going to start with, I think it was M503. Yeah, M503 is a G-code command for, yeah, give me everything you know, basically. So what we need is that line here. Steps per unit. That means 80 steps on X and Y are 1 millimeter in real life. Same about Z, but the most important value is here 392, which is actually, from my experience with that type of extruder, pretty good actually already. But we're gonna see. So now we need to remember that, or yeah, we're just gonna remember that 392. So now we know that machine thinks it moved 100 millimeters. We made a mark at 120, so we can measure the distance between both and get like the real value, how much it actually moved. And we can already see, wow, is that? Look at that. It's supposed to be 20 millimeters, but what we have here is almost 29. So we are under extruding a lot. So now we know that we are supposed to extract 100 millimeter, but we only had 91. So we are going to take 100 divided by 91 times the 392. And that's the new E steps. Yeah, it feels quite a lot, but we're gonna try it out and then we're gonna see if it's good or not. So now to apply these E steps to you know, let the machine learn how many E steps we get, we need to enter M92E and then the steps 400. I think we can even use decimals. 0.77. Yeah, why not? Do it. Okay. Yeah, it says okay. Great. M500 for save. Where is my auto scroll? There. M503 to confirm. Next, where's it? Steps per unit here. There it is. So it's saved, which is great. M82 to finish. Okay. So now calibrating your E steps is, you know, it's like a rinse and repeat. So I'm pretty sure this is quite off. Anyway, we're gonna repeat that. I'm gonna try out if 430 is too much, and then I'm gonna tell you the result. Okay, so there you have it. I settled down at 410.26 for my special snowflake extruder here. Seems to be good enough for me at the moment. Of course, now comes the question, is it worth it upgrading to silent motor drivers? So I'm going to show you a recording from before and after, and then you're going to decide if it's worth it or not. Well, okay, I know that recording isn't really fair because that printer has been running all the time, basically. Didn't want to stop the 2-day print already, so yeah, we got a lot of background noise here, but I think it's still noticeable that the motors are quieter. So thanks for joining in. I hope you enjoyed it. I hope I could help you a little bit. In case you also have an Anycubic and want to upgrade the motor drivers, all the links down below in the description. If you need anything, just post a comment. And that being said, thanks for watching. See you guys in the next one. Bye bye.